So now we're still with 7th period, and we are going to talk about mapping onto itself. According to our district blueprint, there's going to be 2 questions about this. One of the questions is going to be a DOK level 1, and one of the questions will be a DOK 2. So remember, level 1s are easier, level 2s are harder. So we're going to first start off with these 2 questions on page 2. Now, I know page 2, it looks a little bit tricky. Sometimes you're going to have to, in real life, you won't be able to draw on your test, but I want you to imagine, what if we connected these dots, these different vertices to this? What shape would we end up creating? An octagon. And how many sides does an octagon have? An octagon has 8 sides. So if we go back to our magic purple paper, right here is how we do mapping. Right here is how we do mapping onto itself if it's a regular polygon. And basically all we do is we take 360 degrees and we divide it by the number of sides, and then we just keep adding to get what we need. So in this case, I transformed this shape into an octagon. So now I'm going to take 108, or I'm sorry, why did I say 180? 360. I'm going to divide 360 by 8, and that gives me 45 degrees. So I know every 45 degrees it's going to map onto itself. Now here, we're moving from point A to point A prime. So that means I'm making how many turns? Well, this is 1 turn, this is 2 turns, and this is 3 turns. So I have to do 3 rotations to get A to A prime. So all I'm going to do is take this 45 degrees and multiply it by 3. So that means I had to do a 135 degree rotation. Now, okay, that's one way to do it. Another way you could have done it is you could have just done 45 plus 45. Well, if this is 45 here, this is 45 here, and this is 45 here, you could have just added these 45s up. 45 plus 45 plus 45. That gives you 135 also. You could have also estimated it. We know that every quadrant is a right angle, which we know is 90 degrees. So that means from here to here, it's 90. And here to here, it's 90. And we know that A falls less than the 90 degrees. So we could eliminate these and have process of elimination. So either of those ways, any of those 3 ways, will give it to you. Remember, 2 questions are about mapping onto itself. Here's another example. This picture looks a little tricky, but if we just connect the outside vertices, we now have a triangle. A triangle has 3 sides. Now, if you don't remember, in class on Monday, I told you to change this number to 240 degrees. So I have 360 degrees. I divide by the number of sides in a triangle, which is 3. Whoops. And that gives me 120 degrees. So every 120 degrees that I turn it, I'll have a vertice at top again. So I can do 120 times 1 means at 120. If I do 2 turns, that gives me 240. And if I do 3 turns, that gives me back at 360. But remember, we never want to have 360 as our answer. So we know we can eliminate that. So the only 2 choices it could be is choice 3 and choice 4, which is letter D. Basically, 360, because there's 360 degrees in a circle, divided by the number of sides, and then we just multiply to get what we need. Let's jump back to page 7. There's a couple more. Page 7 talks about it being, what about if it's here, it does have a rotation, but anytime you see this and map to itself, I want you to look for the lines of symmetry. And this was on your performance final. And basically, where can I do a line that I can fold it on top of itself? Well, I could do a line right here. If I fold it on this line, I'd get a reflection. It would be on top of itself. And all I did is I noticed this is 4 boxes. Half of 4 is 2. So I just went up 2 boxes, and that's where I did my line. Going across, all the way across, I get 1, 2, 3, 4, 6 boxes. Half of 6 is 3. So this is my other line. And you learned that where the 2 lines of symmetry meet, that is also your point of rotation. So now I know that it would work at this line right here, which is y equals 1. This line right here, which is x equals -2. Or any rotation at the point where they meet, -2, +1. So now we'll look. Well, what about reflecting on across y equals 2? Well, we know that's not true because y equals 2 would be up here, and that wouldn't match up because there's only 1 box here and 3 boxes underneath the line. Reflecting off of y equals x, remember that's the diagonal line. So that means my box would be somewhere down here. So that can't be that one. I could rotate it 180 degrees, but if I rotated 180 degrees around 0, 0, again, it would put me at the same as this. These two mean the same thing. So it has to be choice C, which I already identified. Choice C. So sometimes you would do 360 divided by the number. Sometimes you would have to just look at the problem. Let's take a look at number 4. Here we have the reflection. I'm going to switch to pencil. It has a point at 0, 0 is where it's centered, and 0, 4 is one of the vertices, which will put it onto itself. Well, if we do line M, that means at this point would have to drop down here somewhere, and that wouldn't map onto itself. Reflection on the x-axis, that's this point. So again, that just moves it even farther down. So that wouldn't map it onto itself. Now I have 2 rotations to deal with. Oh, we're going to take our 360 degrees. We know that there's 1, 2, 3, 4, 5 sides, which gives us 72 degrees for every rotation. So similarly to the other page, 72 times 1 is 72, which isn't a choice. 72 times 2 is 144. So that's our choice. Choice D. All right, we're going to stop right here.